Good day, grade 11s. Today I would like to show you how to take into consideration the cast diagram and what the reference angle will be and so on to solve various trigonometric equations. So the exercise I'm going to work on today is exercise 15, and this is from the Via Africa textbook, grade 11 mathematics. So exercise 15, number 4, number 6 and number 8. So we are going to start with number 4 just to warm up, and number 4 states the following: solve for x where x lies between 0 and 180 including both, and then it says cos 2x equals 0,789, and as mentioned, x lies between 0 and 180 including both. Okay, so first things first, we have to determine our reference angle as usual, and we are using our cast diagram also as usual. We can see here that we've got two points of reference now. We have this expression telling us x lies between 0 and 180. That means it could be anything in the first or the second quadrant. The second thing we are looking at is our reference value. You can see it's a positive value. So now we ask ourselves, where is this function, this cos function, positive? It will be in the first quadrant and the fourth quadrant. And now we have the quadrant we need to work in. It's the first quadrant, because only in the first quadrant both of these things it works out. So let's do the calculation now. So first things first, our reference angle. Okay, so to get our reference angle, we have to take the second function cos of 0,789, and that will give you a 37,91 degrees. Okay. Keep in mind, our angle is 2x, not x, it's 2x. So we are going to keep this in mind. So this then means that we only need to get a specific value anyway. So our expression will be 2x equals 37,91 plus k times 360, where k is an element of z. I always write down my equations like that, even though it's a specific solution. And now we have to solve for x. You can see there they ask for x, not for 2x. So now we're going to divide by 2 on both sides. So your final expression will become x equals 37,91 divided by 2, and that gives you 18,96 plus k times 180, because it's 360 also had to be divided by 2, and this is our answer. Now we need to test. This is a general solution. Now to test these values that lie within 0 and 180. So if you make k 0, you get 18,96. If you make k 1, you can see it falls outside of that. It goes into 198,96. If you subtract 180, meaning making k -1, it also falls out. So our final answer is just 18,96 degrees. So this is number 4 of exercise 15. Let's move over to number 6. Okay, so number 6 says the following. It says solve for x without using your calculator if, and then they give us this expression, 2 sine bracket x plus 15 is equal to tan 120. And then they give us another constraint. If x plus 15 lies between 0 and 360. Okay, that's anywhere in the cast diagram, but still this makes it a specific solution and not a general solution, because we're only going to look between 0 and 316. So first things first is we need to get our general solution. We don't have the function on its own yet, so we have to divide by 2, but let's first calculate tan 120. Remember, you're not allowed to use your calculator, so we are going to use our special angles. So right over here we can say sine x plus 15 equals tan 180 minus 60 to get to 120. And remember, we are dividing by 2 on both sides. If you look at your cast diagram, we're working in the second quadrant, 180 minus 60, and that is a negative for tan. So sine x plus 15 equals minus tan 60 over 2. And now if we use our special angles, we know that tan 60 is square root of 3 over 1. So sine x plus 15 is equal to negative square root of 3 over 2. Okay, now let's take it further. To get our final expression, we're working with sine. It's a negative. So with our cast diagram, that would be the third and the fourth quadrant. And we have our value, our reference value, but now we need to get a reference angle. Okay, so if you look at your special angle, triangle, we have a 30, 60, 1, 2, square root 3. If you look at that, and you're working with sine, which is opposite over hypotenuse, we are working from 60, opposite over hypotenuse. So our reference angle will definitely be 60. So we can write that down. And remember, we are working in the third and the fourth quadrant. Okay. So this then means x plus 15 equals 180 plus 60 plus k 360. That's our first expression. Remember to leave a little bit of a space open. And we can write down our second expression, x plus 15 equals, and if you look at the cast diagram, it is 360 minus 60, minus our reference angle. This gives us that expression. Remember to define k. Now let's simplify this. This 180 plus 60 is 240 minus 15. Okay, so it's 225 plus k 360. And then over here we've got a 300 minus 15, so it's 285. Okay, now from here on we can get our specific solutions. And this is 360, that's 360 as well. So if k is 0, we can get a 225 and a 285. If k is negative 1, and negative 1, it falls below 0. And if k is 1, it falls outside of 360. So our final answer is 225 and 285. Okay, and this was number 4. Let's move on to number 6. Let's move on to number 8. Okay, so number 8 states the following. It says determine the value of sine x plus tan x if, and then they give us this expression. Okay, so let's first, so sine x plus tan x, that's what we want to solve. but the information given is as follows. They say cos x is equal to negative 0.341, and they tell us that x lies between 0 and 180. Okay, so before we can get to our actual solution, we first have to define our reference angle, and from there on we can draw our triangle that will help us in solving this equation. So our favorite diagram, the cast diagram. Between 0 and 180, so that is the first and the second quadrant, and cos x is negative. So let's ask ourselves, where is cos x negative? It's negative in the second and third quadrants. So the one we are going to work with is our second quadrant. Okay, now let's determine the reference angle. So shift cos 0,341. Remember, we've already used the negative to determine our quadrant, so we're not using it in calculating the reference angle. So our reference angle is 70,06 degrees. Okay, now we are set up to solve. Okay, by looking at our cast diagram, we can now draw our triangle. So this is our 70,06 angle, and now we can solve for sine x and then tan x, and from there on get our final solution. Okay, now keep in mind that this angle is 70 degrees, 70,06 from 180. So the angle we are working with is that one when determining what sine x and tan x would be. So to calculate that angle, we can say 180 minus 70,06. That is the angle we are working with. So 180 minus 70,06, you get 109,94. Okay, and that is the angle we are going to work with. Can you see how important it was to determine the quadrant, and from there on your little triangle to calculate? So now our expression that we need to calculate is sine x plus tan x. So it's sine 109,94 plus tan 109,94, and then we can get the final answer. Which is negative 1,82. It's actually 816, but we round off to second decimal, so it's negative 1,82. So there you have it. So again, remember the importance of determining your quadrant, use a triangle, and then calculate the unknown.